Good morning, good afternoon, everyone. Thanks for joining today's session on how to deploy manage gateway using gateway operator in Azure. So today we have our speaker, Chintao Zhang, and who is a Microsoft MVP and he works as a senior software engineer. So he is going to take us through the session and help us better understand this topic. And before we get into the session, I just want to share that this session is recorded and will be shared in our YouTube channel, and you can refer it again whenever you want it. And secondly, there is certificate of participation to those who stay till the end. So at the end of the session, I will share a form, basically a feedback form. You can fill it out and receive your certificate of participation. If you love the session, if you love the information that is being shared here, please to join the community so that you do not miss our upcoming session. And thank you everyone to again to join session. I hope you guys enjoy session and the stage is all to Jintao. Over to you.
Okay. Okay. Thank you. Thank you everyone for joining this section. Uh, Let me start my session. Yeah. Okay. I will in this session I will show you how to deploy manage the gateway using gateway operator in AKS. Okay. Before the content, I will introduce myself. My name is Jing Tao, and I'm one of the Microsoft MVP in Azure direction, and I'm the one of the maintainer of the Kubernetes Ingress Nginx project, and I'm working for Con Inc. Yeah. Uh, in this slide, uh, below is my GitHub link and my Twitter link. If you have any interesting, you can contact me. Yeah. Okay. So let me introduce the agenda. The first one I will introduce the networking in Kubernetes or in AKS. The second one, I will introduce why the managed gateway is needed. Then I will show you uh, Con Gateway Operator project. The last part, I will show how to deploy a managed gateway using KGO in AKS. Okay, first part, I will introduce networking in Kubernetes or in AKS. Okay. First, one, I will introduce what does networking in Kubernetes include. Well, as we know, Kubernetes is a power platform for automating the deploy, scaling, or operations of application containers across cluster of the host. However, for these containers or for pods, as they are known within the Kubernetes realm, to effectively communicate and service their purpose, a robust networking model is essential. Let's dive into the component that networking in Kubernetes. Firstly, we have the communication between pods on the same node. This is the most basic level of the networking within Kubernetes. Pods running on the same physical or virtual machine need to communicate with each other. Kubernetes use the networking namespace and other installation machine provided by the underlying operation system to ensure that these pods can connect effectively and securely. Move on to the move a step further. Uh, we say we have one communication between pods on different nodes. As our application scaling, they span across multiple nodes, creating a need for cross-node communication. Kubernetes abstract the complex involved in this process. Initial pods can communicate seamlessly. Uh, they can communicate uh, things from one node to another node. Yeah. And next level, I will let's talk about service. A service is a Kubernetes resource and it's abstraction that define a logic set of pods and a policy by which to access them. This abstraction enables the doubling of the backend of pods implementations from the front end service that accesses them. Service allow for stable communication pathway between different components of the application. Then we will talk the ingress and egress. Ingress and egress machine in Kubernetes is management of the incoming and outgoing traffic to your cluster. Ingress control how external traffic reach your service within the cluster, allow you to define accessible URL, load balance traffic, uh, terminate SSL, and offer name-based virtual hosting. Egress, egress, egress on the other hand control the outbound traffic from your port to the external world, ensure that only authorized connection are made, thus enhance the security of the cluster. Although Kubernetes doesn't have a native egress resource, but Kubernetes has the ingress resource, uh, but some other component provide this implementation, such as the Calico. Last, we have network policy. Network policy, this is a specific of how group of pods are allowed to communication with each other and uh, other network endpoints. Network policy are critical for enforce security rules and ensure that only the needed traffic can follow between pods, service, and external worlds. There are the basic conception that will be in enter when discussing Kubernetes networking. However, these concepts require some specific components to implement their function. Then I will we will discuss Kubernetes networking components. The first one is CNI implementations. Uh, the CNI is the container networking interface. It's a it's a specification, and the CNI have some plugin to its the CNI implementations. Yeah. Okay. Uh, the CNI has a set of tools that implement the networking interface for containers. Kubernetes rely on CNI implementations to provide in-pod networking capabilities. These implementations, such as Calico, Flannel, and Cilium, to name a few, allow for pluggable framework that supports a wide range of the networking feature, include networking segmentation, policy enforcement, and overlay network. Choose the right CNI implementation is is critical as it influences the networking performance, security, and scalability of your Kubernetes cluster. For example, a few years ago, Flannel, which was widely used, but the project didn't provide network policy support. Therefore, if this CNI plugin is used, network policy can't take effect. However, in addition to the native network policy resource, Calico and Cilium have also implemented their own enhanced version of the network policy. Yeah. The next one is the Kube proxy. Kube proxy, in every node we will run a Kube proxy, and sometimes if you're using the Cilium, Cilium can be a replace of the Kube proxy. Yeah. Okay. The Kube proxy is responsible for maintaining networking rules on the node. The rules allow network communication to your pods from network sessions inside or outside of your cluster. Kube proxy, uh, Kube proxy enables the forwarding of the TCP and the UDP package to pods based on the IP and port number of the incoming request. Through service, Kube proxy abstracts the IP address of different pods, ensure that the internal networking structure is hidden from the external client. Yeah, it's networking. Yeah. The next one is DNS. In every Kubernetes cluster, you will find a service name named Kube DNS. Yeah. But it's run on core DNS pods running. Yeah. In the realm of the Kubernetes, DNS play a pivotal role in the service discovery. It allows pods to locate each other and external service through human readable name. When a Kubernetes cluster is created, a DNS service is automatically deployed. Assign a DNS name to other Kubernetes service. This simple communication with the cluster as pod can reach each other on and external resource using this DNS name. Enhances the overlay application architectures flexibility and robustability. Yeah. The last part is the controller. I will show two controller. The first one is the IPIM. IPIM is the short name of IP address management. This controller is critical for managing the assignment of IP address to pods and service. Effectively, IPIM practice ensures that there is no conflict between the IPs assigned with the cluster, maintaining a small network operation. The next one is endpoint slice or service controller. Yeah, this comment works together to manage how external and internal communication reach the pod. Service define a logical set of the pod and a policy by which can access them. The endpoint and endpoint slice keep track of the IP address of the pods that are associated associated with each service. This system ensures that networking traffic is effectively routed to the pod, allow for the scalable and reliable application deployment. Although they they may appear complex, uh, but they all follow the most basic model. Yeah, it's the Kubernetes networking model. Yeah, the Kubernetes network model uh, includes three parts of concept. Yeah, the first one is each port has its own IP address. Yeah, the Kubernetes networking model is designed to ensure communication with the cluster, which is pivotal for deploying scalable and resilient applications. Uh, yeah, uh, each port has its own IP address. Uh, this part is uh, if you deploy a pod in a Kubernetes, each pod is assigned its own unique IP address. This is very important, and uh, it have some difference from the traditional deployment where containers or applications with the host might share the host's IP address. This unique IP uh, per pod simply application configuration and mm, it means that each pod can be treated as if it's a physical host on the network, making network policies and communication more straightforward to the manager manage. Uh, the next one is all pods can communicate across nodes without the need of NAT. The last one is the components on the node, for example, kubelet or uh, or DS can communicate with all pods on the node. Yeah, uh, these two rules has been introduced early, and they defined how they define how pods are accessed. Yeah, so we can skip the last two rules. Yeah. Okay. Uh, let's think how to access applications deployed in Kubernetes cluster. Uh, we know deploy application is the only part of the journey, and the critical abstractor is aspect is how these applications, once they deployed, are made accessible to the outside world. The first one is node port. You know, uh, node port is a simple yet powerful way to access your application. When you configure a service as node port, Kubernetes exports that service on each node's IP at a static port. It, the port's number is the same as the service node port. Yeah. Node port service is accessible by the IP of the node. It's running on combined with a high port number assigned specifically for the service. This means that anyone who can reach the node either with the internal network or from the outside world can access the service by hitting the node's IP at the and at the designated port. This method is particularly useful for deployment environment or small setups where direct access to each node is manageable. However, it's worth nothing that managed access through node port can become a challenge in environment with a large number of nodes, as it requires keeping track of the multiple IP address and port. Yeah. So then the next one is the load balance. Uh, Moving to a more the load balance, this method integrate Kubernetes service with the external existing uh, cloud provider load balance. For example, if we using AKS on the Azure, yeah, AKS, when you create a service of the type load balance, Kubernetes provides uh, Kubernetes provider or cloud load balancer for your service and direct external traffic to it. This external load balance then uh, automatically routes the traffic to your Kubernetes pod. Uh, uh, and it don't care which node your pod is running on. Yeah. The beauty of using load balance is its uh, simplicity and scalability. Yeah, it abstract away the complexity of dealing with node IPs and ports, provide a simple single entry point. The load balance IP, everyone can just access the load balance the IP and don't care the node, the Kubernetes clusters nodes IP. Yeah. You can just use the Lawrence IP to access your service. This make it an ideal choice for production environment where you're using the cloud provided environment. Yeah, but sometimes you can use some other project. Yeah, for example, you can use Metal LB. Yeah, the Metal LB you can deploy the Metal LB into your private cluster, and it can act as the cloud load balance. It will create L2 L2 uh, I L2 L2 IP, yeah, to let to expose an IP, and then you can just use the IP to uh, access your service in the cluster. Uh, Whether you opt for not port for the simplest direct access, or load balance for its robustness and scalability, Kubernetes offer flexible solution to suit different application access needed. But you maybe uh, you may have a question. In most cases, we talk about accessing application inside the cluster through ingress from the outside of the cluster. What exactly is ingress? Yeah, what is the ingress? The ingress, the in, at its core, ingress is not a tool or a component. It is a powerful API object that provide abstractor of uh, how the traffic out of the cluster to access your service in the Kubernetes cluster. It allows you to define flexible HTTP-based routing rules that direct traffic to different service based on the request detail. Let's see the example in the right of this slide. Yeah, you can see. in the ingress resource, we can define the spec. Yeah, the spec can include the spec can include many rules. Rules. Yeah, every rules you can define the host and the path, and you can define the TLS is the certificates. Yeah, the host the host field in the host field in an ingress specification is what allow us to define domain name that will be routed to specific service within our cluster. This means that you can have different domain name or subdomain point to different part of your application, all managed through a single ingress resource. This is particularly useful for applications that require multiple entry point, or for hosting multiple services under the same cluster. Yeah. The next one is the passes. Yeah. Passes. This field works in works with the host to provide even find the control of the routing of incoming request by specific path. You can direct traffic not just based on the domain name, but also based on the URL path. For example, request to example.com slash API could route to one service, while request to example.com slash blog could be directed to another. This allows for a highly customized and efficient distribution of the traffic to the uh, various components of your application. Yeah, the last one is the TLS, is the certificates. Yeah, uh, particularly the useful of SSL or TLS certificate to encrypt traffic. Ingress allow you to specific certificates for each host, ensure that all communicate is security encrypted. This integration of SSL or TLS certificates with Ingress means that you can manage the security of your service at the same point where you are managing. They are accessible simply to the overall configuration and maintenance of your applications. Yeah. However, simply creating an ingress resource is not enough for it to work. Yeah. Uh, so maybe you want to know how does ingress work? Yeah, I have draw a follow to describe how the ingress how the ingress work. Yeah, at the heart of the ingress machine lies the ingress is the ingress controller. This isn't just an ingress control. This isn't just an controller. It's a component of networking traffic. Uh, and it can define how requests from outside of the Kubernetes cluster are handled and direct. But how does it achieve this? Yeah, the ingress controller will continually monitor the Kubernetes API for ingress resource, the rules and the paths that you defined for routing external traffic. Upon detecting an ingress resource, the controller spring into action. translating these high-level ingress rules into specific or actionable to data plane rules. This translation process is where the abstract uh, uh, become turning our defined path and domain into uh, instructions on how traffic should flow. Yeah. The next one is the data plane. The data plane, the data plane will carrying traffic to its destinations. When the rules translated, we now turn to the data plane. The data plane is the physical and logical network path that actually traffic flows through. Yeah, the data plane is where the robust meet the rate, or more uh, apparently where the packet meet the where the packet meets the port. In the concept of the ingress, the data plane is responsible to carrying the external traffic. Now governed by the rules set forth by the ingress controller. It can involve the various of operations such as SSL termination, load balance, and content-based routing, all performed with the goal of ensure that incoming requests are delivered to the correct service with the cluster. Yeah, usually we create a service for the data plane, and then I export it to external access by using node port or node planes, as I mentioned earlier. Yeah, you can see this picture. Uh, if we deploy an ingress controller, sometimes the ingress controller can deploy the ingress controller and the data plane in two different pods, but sometimes it can deploy into the same pod. Yeah, but we need a service. We need a service to expose the data plane to to outside of the cluster. Yeah. So if the client's uh, request to the service, then this service will direct the traffic to the data plane. Then data plane will check its configurations, then uh, direct the traffic to the um, to correct ports or service. Yeah. So what's the limitations of ingress? Uh, One of the core limitations of the ingress lies in its limited uh, expansive. The ingress rules are designed to be straightforward, focusing primarily on HTTP and HTTP routing. Uh, this simply will beneficial for ease of use and understanding. Means that Ingress can't native handle most complex routing scenarios. For example, Ingress don't support advanced load balance don't support advanced load balance, TCP or UDP traffic routing, or canary deployment out of the box. Sometimes when you're using a ingress controller, for example, Kubernetes ingress controller, or for example, call ingress controller, you will find it can support you to define HTTP protocol, gRPC protocol, or gRPCS protocol, but it's not includes in the ingress resource specification. It's just extended by these ingress controller implementations. Yeah. And then another limitation is that is the way ingress extender is functionally. As I mentioned, uh, it's uh, when the ingress when the ingress controller implementations want to extend the ingress function, it through annotations. Each ingress controller, such as the ingress index, call ingress controller, or HA proxy, may implement additional feature that are not part of the standard ingress specification. These features are often enabled or configured via annotations in the ingress resource. While annotation provides a flexible way to extend the ingress capability, they also introduce um, variability and complexity. Different ingress, they also introduce complexity. Different ingress controller might support a different set of the annotations, leading to a lack of standard across the implementations. This can result in uh, portability issue when moving applications between cluster using different controller. Furthermore, relay relying heavily on annotations can make ingress resource clustered and hard, harder to manage, especially as the number of the annotations grew to uh, accommodate more complex configurations. Yeah. For example, if you want to switch from the Kubernetes ingress controller to con ingress controller, or from con ingress controller to another ingress controller, you will find it's hard uh, to make all of the annotations can do the same thing. Yeah, and you need to change the annotations configurations. Then you need to test the behavior of the data plane. Um, after you verify all the behavior doesn't change, then you can do the migration from one ingress controller to another ingress controller. Yeah. Okay, let me introduce the advantages of the Gateway API. It's the next generation network standards. Yeah, considering these limitations of ingress, the Kubernetes community decided to make some change and thus began the design of the Gateway API. Yeah, the Gateway API was born in the KubeCon. Yeah, Gateway API offer several key advantages that make it an abstractive choice for managing networking traffic in Kubernetes. First one is the role-oriented, yeah, oriented. Gateway API is designed with distinct role for different type of the users. This allows for a more fine-grained and role-specific way of controlling access to the resource. improving security and make the management of permissions more straightforward. For example, cluster operators can control infrastructures related aspected of the gateway and the resources where developer can just manage the application level configuration. For example, the developer can just configuration the configure the HTTP router or gRPC router or something else. Yeah. The next one is more universal. Unlike Ingress, which primarily focus on HTTP and HTTPS traffic, Gateway API is a protocol. Uh, Gateway API has a set of uh, resource to define how to handle the behavior for different protocol. For example, the Gateway API supports HTTP router, gRPC router, TCP router, UDP router. Yeah, uh, I and for now, uh, the Gateway API has released the v1.1 point RC1 version. Yeah, in this version, the gRPC router has been GA for now. Yeah, so you can just use the native gRPC. You can use the native gateway API's resource to define how to deal with the gRPC route. Yeah. Okay. The last one is vendor neutral. Yeah, Gateway API is designed to be vendor neutral. Means it doesn't favor any specific networking solution. This ensures that it can be used consistently across different environment and networking solutions, enhance portability and reducing window locking. Yeah, in Gateway API project, they have a conformance test. Uh, any Gateway API's implementations can run the conformance test. If they pass the conformance test, means its the behavior is the same as other implementations. Yeah, you can if you want to choose um, choose an implementations of the Gateway API, you can check the conformance test profile to see which features the implementations has supported and which feature they passed the conformance test. Yeah. Okay. I will give you a detail of the role or oriented. Yeah. In the context of the Kubernetes Gateway API, being role oriented means that the API is designed with distinct rules for different type of user. This approach allows for a more fine-grained control of the resource, improving security and making the management of the permission more straightforward. For example, the role the rules could be divided between cluster operation and application developer. Cluster operation control infrastructure related resource, for example, the gateway class, uh, and the application developers can just define the TLS route or HTTP route. The role-oriented design allow each user to focus on their area of the of expertise without needing to worry about the details that are outside of their focusing area. Yeah. It also ensures that only authorized user can make change to specific resource of the configurations, enhance the overall security of the system. Yeah. Okay, let's discuss why the managed gateway is needed. In this part, I changed the title to why multiple tenant gateways are needed because the net because sometimes the multiple tenant gateway means managed gateway. Yeah. Okay. Uh, so why we need the multi-tenant gateway? The we have some reason. For example, we want to uh, simplify the management. Uh, I remember I before I for maybe 4 years ago, yeah, uh, in in the company I worked for, the company set all of the all of the proxies configuration into one cluster. Yeah, so we have a very large configurations that contain uh, two 200,000 of the configurations. Yeah, no one can't modify the configurations, and no one can improve the configurations. Yeah, it's very large. But if we create different gateway for different user, yeah, the configurations can be very small and manage the gateway, handle the underlying infrastructures, freeing up development team to focus on application logic. Uh, this simplifies the management of the gateway as the complex of configuration, maintenance, and upgrade are handled by the provider. Yeah. Another one is scalability. Managed gateway offer automatically scaling capability. They can scale up to handle high traffic loads and scale back down during during the low traffic scenarios. Yeah, and it can they can save the cost of the resource. Yeah, another one is the uh, reliability. Managed gateway provide a high available and fault tolerance. They are designed to maintain service continuity even in the face of networking dis, uh, disruption or hardware failures. Yeah. Uh, the next one is security. Security. A managed gateway often come with a built-in security feature such as the SSL, uh, encryption, and identified-based access control. This ensures that your application are security and your application can have a different uh, authorized method with other different service. Yeah, and In solid and protocol telnet traffic, reduce the blast radius. Yeah, and we can see here has some general solution. The general solution is to deploy multiple sets of the ingress controllers, but and sometimes they have two common solution. One is distinguished by ingress class. Another one is distinguished by namespace. Uh, if the different configuration, uh, different configurations through ingress class. Ingress class is a Kubernetes resource that allows users to specify the type of the ingress controller they want to use in their application. By defining different ingress class, users can just associate their ingress resource with the specific ingress controllers. This is a benefit as it allows for a clear um, separation and management of different application traffic with the cluster. Each ingress controller can handled by themselves. Yeah, and another one is to deploy ingress controller in the namespace scope. Yeah, another if you deploy the ingress controller in the uh, namespace the scope, yeah, it can it can just enhance the security and organizations of the cluster as it provides a clear uh, separation of the uh, concerns between different application and their respective ingress controllers. Yeah, and but there have some pain points. Yeah, for example, where deploying the multiple ingress controller in the same cluster might have some uh, pain points. For example, increase complexity. Manage multiple ingress controllers increase the complexity of your Kubernetes cluster. Each cluster has its own configurations and behavior, leading to potential inconsistencies and conflicts. This can make it hard to predict how the controllers will uh, interact and debugging effort one issue arises. Uh, Another one is resource waste. Yeah, if we deploy a lot of ingress controller, uh, when the ingress controller is running, we will need to uh, waste some CPU or memory for the ingress controller. Yeah, and it will increase the resource uh, wastage. Yeah. Another one is the increased maintenance. With multiple ingress controller, you need to maintain each one uh, separately. Uh, for example, if you want to upgrade the ingress control, yeah, you will find you need to upgrade them one by one. Yeah, and it will lack of the uh, centralized control. Yeah, uh, if you have a set of ingress controller, yeah, you will you will find you have a lot of different you have a lot of configurations for different cluster for different ingress controller and different when they bump to different version, sometimes you need to change the configurations, and uh, you can't know you don't know other configurations does other configurations can work still. Yeah. And another the last one is security risks. Because if you when you deploy the different set of ingress controllers, maybe every controller will uh, can have some risk, security risk. Yeah. Uh, when if you don't upgrade them to the latest version, you will find some security. Yeah. Okay. So consider all of this. Let me share with you an innovative open source project created by Con known as the Con Gateway Operator. This project is not just another tool in the teach space. It's a game changer designed to address some of the most pressing challenge we face in managed API gateway. In our journey, in our journey towards digital transformation, we often encounter that uh, there have some problems. The Con gateway operator is here to resolve these problems by offering uh, the one is for lifecycle management. The life cycle of the Con gateway has never been easier. From deploy to uh, retirement, the Con gateway operate issues the small journey. Moreover, it supports a blue-green strategy for upgrading Con gateway, making the transaction seamless and minimal downtime. Yeah. Uh, and another one is to elastic scaling. Cost efficiency is uh, is the more is very important in today's landscapes. The Con gateway operator leverage HPA and lattice machine to dynamic scaling your resource. This not ensure uh, optional performance, but also reduce the operational costs. Yeah. And another one is automatic certificate rotation. Security is a top priorities, and uh, the KGL project through integration of the cert manager, it can do the automatic certificate rotation. Uh, the last one is the AI gateway support for AI gateway. In for now, we know the AI and LM has growth up very fast. The Con gateway operator sets a state by uh, prioritizing the AI gateway support. This feature is designed to streamline the development and deployment of AI-driven application, making it easy for developers to integration cutting edge technical into their solution. Um, Another feature is the HA based HPA based auto scaling. Uh, I I would like to show an example of KGO's uh, automatic scaling configuration based on HPA. Just you can just specific the scaling up and scale up and scale down in the spec dot deployment dot scaling field section, and everything needed will be automatically completed. Yeah. Okay. The last part is how to deploy manage the gateway using KGO in AKS. I think it's very the deployment is very simple. You can just need to create AKS and deploy the KGO. Uh, After the KGO has running, you can just create configuration fields and create a gateway class resource, create a gateway resource, then create the routing resource such as HTTP route. Uh, Let me show your command for deploy the KGO. The KGO, the con gateway operate, we call it KGO. Yeah, we have provided a ham chart. You can just using ham repo at then ham repo ham install or ham upgrade install the KGO. After you deploy the KGO, then you need to create a configuration named gateway configurations. The configurations will define the data plane options or control plane options. If you want to deploy the uh, con gateway only, you just need to define the data plane options, and you don't need the control plane options. Yeah, but if you want the con can act as the ingress controller, you can just define the control plane options and the data plane options. In control plane options, you can deploy which version of the ingress controller you want to use. In the data plane, you can just deploy. You can just specific which version of the con gateway you want to use. Yeah. After you create this resource, you can just create the gateway class resource. Yeah, the gateway class is uh, infrastructure's resource. Yeah, uh, it will be provided by the clusters operators. Yeah, in gateway class resource, you can just specify the controller name and parameters refer. Yeah, it will refer to the gateway configurations. Then, if you create gateway, create the gateway resource, then the gateway operator will check the gateway class resource and find the gateway configurations to check which deployment you want to use. For example, if you only want to deploy the con gateway, or you want to deploy the con gateway and the ingress controller, yeah. After you create a gateway resource, the gateway resource you can define which port the gateway want to listen and which protocol the uh, gateway want to use. Yeah. Uh, after the gateway class and the gateway resource created in the cluster, you can create the router resource. For example, if you create, you can create the HTTP router to uh, router your traffic from the client to your service deployed, which deployed in your Kubernetes cluster, and you can define the TLS router, gRPC router, TCP router, UDP router, or something else. Yeah. Okay. That's all. Thank you for joining this session. It's my all of my content. If you're interested of the Khan Gateway operate, you can check this link. Thank you.
Thank you, Chinta, for the session. Really appreciate that you took your time and joined the session and share it with them. And if there is any resources that they can use, feel free to drop it in the chat box, and they can use or make use out of it. So everybody,
Oh,
thank you for
right.
joining as well. And yeah, I will share the form, and we'll also upload the video recording in YouTube, so you can watch it if in case you missed out the first part or you want to rewatch it. So please do make sure you join the community as well. We'll have more sessions coming up from these kind of topic, and yeah, hope you guys will enjoy the upcoming sessions as well as much as you enjoyed this one. Okay, let me just share the certificate of participation, and yeah, that's it for the day. And if you have filled out the form, you can leave the session after you join the community. That is, uh, yeah. Let me share.
Okay.